Okay, this recording is about significant figures and why they're important. A definition for significant figures is in a measurement, the significant figures consist of all digits known with certainty plus one final digit which is going to be your estimation. Well, what do I mean by that? Let's take a look at this ruler over here. So this ruler is in centimeters. This is the object we are measuring. We know for certain that the object goes past the 11 centimeters. We also know for certain that the object goes past 1, 2, 3, 4, 5, 6, the 0.6 centimeters, but we're not quite sure where it lands between 0.6 and 0.7. So that would be your final digit, your estimated digit. So I think it's about halfway in between. So I'm going to say our object is 11.65 centimeters long. So the 11 and the 0.6 are digits of known certainty because my instrument, I can tell for certain that it goes past those graduated lines. But the 5, here is an uncertain or estimated digit. So that is my last piece of information that I would get from this ruler. The reason sig figs are so important with measurement is you can only be as accurate and precise as your least accurate or precise tool when you're in lab and you're collecting data. So I just don't want numbers that are made up. I want them to mean something. They are significant. They give you information. When you are given a number, there's rules for counting sig figs. First of all non-zero numbers are significant. That means digits 1 through 9 are always significant, so you will count them. Sandwich zeros are always significant. So if you have the number 702, sandwich 0 in the middle, that one is a significant digit. Now, trailing zeros, so that's a 0 after numbers, are only significant if a decimal point is present. So here's a decimal point. These zeros are going to be significant. I'm going to count them. But if the number was 702,000 and there is no decimal present, suddenly these zeros are just placeholders. They just tell you how large or small the number is. It doesn't give you any more data, so they are not significant. Leading zeros, so zeros in front, are never significant. So 0.002. These are leading zeros. Those are not significant. So if I was to look at my first number I gave you, 702.000, and I was to count my significant figures, I have 1, 2, 3, 4, 5, 6 significant figures. Because all non-zero numbers are significant, all sandwich zeros are significant, and because this decimal is here, these 3 zeros afterwards are also significant. The trailing zeros are significant if a decimal point is present. But in this number, there is no decimal point. So the trailing zeros are just placeholders. They are not significant in giving us any more data. So we do not count them for sig figs. In this number, there's only 1, 2, 3 significant figures. So let's do some more practice. 3.824 liters. Well, these are all non-zero numbers. So since we have 1, 2, 3, 4, there are 4 sig figs. 240 meters. Notice that we have 2 non-zero numbers, so those are going to be significant. But we have ourselves a trailing zero. Well, trailing zeros are only significant if decimal point is present. No decimal point, so we only have 1, 2 sig figs. Leading zeros, so zeros in front of the first non-zero number, we never count them as significant. They're again just placeholders. We have 1, 2, 3 sig figs. Then, sorry about that. Okay, so if we have the number, we have the number 2.1 times 10 to the 4th. This is in scientific notation. The nice thing about scientific notation is that any number before the times 10 is going to be significant. That's the reason we left it when we wrote our scientific notation. So we have 1, 2 significant figures. It will take some practice getting used to using significant figures, but it is important because it gives us a reflection of how accurate and precise our measurements are. Alright, calculating with sig figs, there's 2 rules. One rule with multiplication and division, one rule with addition and subtraction. When you multiply or divide, your answer can only have as many sig figs as the number with the least number of significant figures. So basically, look at all your numbers, count all the sig figs. In the calculation, the number that has the smallest amount, that will determine the number of significant figures in your answer. So let's take a look at this. So here we have multiplication and division. We have a lot of numbers here, and they have different amounts of significant figures. I've already calculated the answer. This answer here is not given in significant figures. So I need to change this answer so that it actually reflects precise and accurate data. So 239.1 has 4 sig figs. 46.23 has 4 sig figs. 0.00290, well, we've got leading and trailing zeros. Leading zeros, never count them as significant, but because we have a decimal, this trailing zero does give us information, so this has 3 significant figures. 16.508, we have a 0, but it's sandwiched, so that's definitely significant. So 1, 2, 3, 4, 5 sig figs, and 114.9, 1, 2, 3, 4, 5 sig figs. Well, the number with the least amount of sig figs is 0.00290, 3 significant figures, so our answer can only have 3 significant figures. You start counting significant figures at the first non-zero number. If there's a decimal present, you start from the left and move right. So we have 1, 2, 3. Okay? So we are looking at the 169, and then there's a 9 afterwards. So 0.0, we must write these zeros, the leading zeros, even if they're not significant, because they tell us about place holding, how large or small the number is. 1, 6, okay, our last sig fig is 9, but look at the number right after it. It's a 9. Remember your rounding rules. So you're going to round up, okay? So we are going to actually round that 9 up to 10, and that makes this a 7. But we don't have yet 3 significant figures, so we must write our 0 afterwards. So now we have 1, 2, 3 significant figures. If you were to write this in scientific notation, it looks like this. If you are doing addition and subtraction, you can only carry out the answer as far as the first doubtful digit. So basically, count the decimals. Count the decimals. It is not how many significant figures are present, it's how many decimal places there are. Okay? So you want to go to the least amount of decimal places. This one goes 2 past the decimal, this one goes 3. So 2 is the smallest amount, so we are only going to go 2 places past the decimal, 42.36. I did not round the 6 up because the number after it is a 1. So it stays the same. Remember your rounding rules. If it's 5 or above, then you round up. Otherwise, leave it how it is.